Okay, in the first video we watched, we talked about how to study chemistry. We have this big broad topic of matter, and it helps if we can categorize matter into smaller chunks and study those smaller chunks. And the categorization that we're going to talk about today and start with on this video is called the classification of matter. It is one way to group matter into various categories. The first category we want to look at that we've already started examining is a category of elements. And we learned that if you had substances that all had the same atom, that would be considered an element. So for example, if we took a piece of aluminum foil is made up of all atoms of aluminum. And each atom, we learned from our POCL activity, has 13 protons in it. So if I had a bunch of atoms and they all had in common that they had 13 protons, and we grouped them all together into one piece, we would say that we had the element of aluminum. So that's our first category, elements. Now this category can be further broken up into other categories. So we're going to look at subcategories of the group of elements. And this is going to be arranged around the color scheme that you see on this periodic table. We see that some of them are blue, most of them are blue. We have a few that are this peach color, and this hydrogen over here all by itself really belongs with these. Okay, and then we have this little purple area down the middle. The first group that we're going to examine is the big blue area. The big blue area are your metals. Now we said that when we categorize things, we do this because if we can study that whole category, we would know something about everything in that category. So we generalize about it. The first thing that we can say are and these would be the properties of it when we generalize. They are all shiny. Now what that means is they simply reflect light in a way that is very representative of being a metal. They are all opaque. That means light doesn't pass through the metal at all. You can't see through it. You can't pass light through it. Now, that doesn't mean that everything that's opaque is a metal, but every metal is opaque. They're malleable. You can hammer them into shape. If I were to take this nice piece of gold here that this person is holding and hit it with a hammer, it would just get a dent in it first, and if we keep on hammering, I could hammer it out into a very, very, very thin sheet, and it would never break. They are also ductile. Now ductile means you can draw it into a wire. You may not have ever thought about how a wire is formed. They don't have big long molds that they pour molten metal into and they form into a shape of a wire. But what they do is they grab the piece of metal by two ends and they start pulling. And they pull hard in two directions, and it will pull thinner and thinner and pull out into the shape of a wire. And lastly, we have that they are conductive. They will conduct both heat and electricity. If I were to put a metal pan with a metal handle on the stove, eventually that metal handle would get very hot because the heat is conducted up through the pan and down the handle. They also conduct electricity. Our wires in our homes are made out of metal because they allow the electricity to flow into our light fixtures and whatever else was run by electricity. Okay, over on the far right of the periodic table, where it was the peach color, we have our nonmetals. And basically our nonmetals are everything that is opposite of being a metal. So the properties that we know that metals have, the nonmetals will not have those properties. So they're not shiny. Now this is bright in color, but it doesn't reflect the light and give you a shiny image like the metal does. So it can be the same yellow like gold is yellow, but it doesn't have that shininess to it. Now some of them are transparent. I said that not everything that is opaque is a metal. Some things are opaque. This is opaque, doesn't allow light to pass through it. But some of them are not only allow light to pass through it, but you can actually see through it, and that's what transparent means. Most are brittle. This is a piece of sulfur that if I hit with a hammer would just shatter into a whole bunch of pieces. It would not flatten out. Cannot be drawn into a wire. If I pull, it's just going to break in two. It's not going to draw into a wire. And it will not conduct heat and will not conduct electricity. So those are your nonmetals. Now in between the metals and the nonmetals on the periodic table was a little purple band. This little purple band is where the metalloids live. And the metalloids have some properties of metals and some properties of nonmetals, all contained within the same element. For example, this is a piece of silicon. If I were to hit it with a hammer, it would shatter. But it definitely conducts light. We see a shininess to it. It's not conducting light, that's silly. It has a shininess to it. Under normal temperatures, it doesn't conduct electricity, but if I were to change the temperature, I can get to a point where it will conduct electricity. And that is a very definite property of metalloids, where they have regions where they don't conduct electricity, and above a certain temperature they start to conduct electricity. Now you have a star next to acetine, and I just want to mention a little bit about that. It's just because some periodic tables include it, would say it, some textbooks, some websites would call acetine a metalloid, and some would not. So we have it here on this periodic table listed in purple. So this periodic table is saying, oh, let's call it a metalloid. If you would look in the front cover of your textbook, there is a periodic table, and it is also color-coded, and it did not include acetine as a metalloid. Some textbooks and websites would say polonium is a metalloid, and some would not. So these two are kind of up in being up for grabs as to whether they are metals, nonmetals, or metalloids. But everything else that you see in purple, there is no question about it. Now, when you get a periodic table, it's not going to be color-coded like this on a test, but you need to know which ones are metals and which ones are nonmetals and which ones are metalloids. So you need to be able to draw this imaginary line here. It starts under boron and it stair-steps down. Okay, so if you can stair-step it down, and I'm trying to do so with my red pen here, down to the right, and then go on either side of that line. Those are your metalloids, above and below, except for one very notable exception. Aluminum borders that line, but it is all metal. There is no doubt about it. There is no question about it. It has all the properties of metals, and so it is a full metal. But everything else that is bordering above and below that line is going to be a metalloid, except for these two that there's debate about what you're going to call them, and I will never ask you about those two. Now, I've changed the heading, but you still have the same periodic table you're looking at. There's certain elements that you need to know the name and the symbol for it. You need to know the name and the symbol. If I were to give you the name, you should give me the symbol. If I were to give you the symbol, you should know the name. When you take tests, you'll be given a periodic table that doesn't have names on it. So if I talk about the element sodium, you need to know where to look on that periodic table. But I'm not going to make you know every one. I'm going to circle some that you need to know. Now I'm going to give you the names, and you may be able to write them down and stop the video and to catch up and get them all in. Or you can go to the front of your textbook, and there is in the first few pages, there's a periodic table, and then there's a table that lists them all in alphabetical order with their names and their symbols, so you might want to write them down that way. But let me circle them and go through them each. Hydrogen is H, so you need to know that name. Over here on the right-hand side, I've circled a few here. We have number 2 is helium, number 5 is boron, 6 is carbon, 7 is nitrogen, 8 is oxygen, 9 is fluorine. A lot of people want to call fluorine Fl, but it's just F. 10 is neon, so neon lights are made out of that element. Coming back over here on the right-hand side, a few more to know, and I'm only picking out the ones that are really common, and that's why I skipped lithium and beryllium up there, 3 and 4, but I want you to know Na is sodium, Mg is magnesium, K is potassium, and Ca is calcium. Over on the right-hand, right here in the middle, is iron, Fe. You need to know its symbol is Fe. Continuing to the right, we have 13 aluminum, 14 silicon, 15 is phosphorus, 16 is sulfur, 17 is chlorine, 18 is argon, and just a couple more. I want you to know Br is bromine and I is iodine. So those elements, you need to know the names and the symbol for them. Okay, so we're categorizing. I categorized elements, and I categorized further those elements into metals, nonmetals, and metalloids. Well, all of these are considered pure substances. If you have all of one element, you've got a pure substance. But there is another thing that is considered a pure substance, and that is what I've got shaded here in green, and that is compounds. So this is another category. It fits under a category called pure substances. Pure substances are either elements, which we've just talked through, or they will be compounds. So what's a compound? If you ever look really closely at table salt, if you looked at it, you see little bitty cubes. You look really closely. And this is because this is actually how those atoms that make up this compound arrange themselves in little cube shapes. This is the compound of sodium chloride that you see to the right here, and that's table salt. So this is the definition of a compound. Two or more types of atoms in a fixed ratio. So that has to be a fixed ratio. I can't have, it won't be table salt and sodium chloride if there's 2 sodiums for every chlorine. So there's a fixed ratio. It's got a uniform composition throughout the whole structure, and it cannot be easily separated into their pure elements. You can't just pick them apart. It's a difficult process to separate them into their pure elements. When you form them from their elements, when you make a compound, this usually involves giving off a lot of energy. We see here a bright light coming out of this flask. What's happening here is they've put a piece of sodium metal into some chlorine, and it just reacts very violently and gives off a lot of heat and a lot of light. And those compounds, once you have them, do not have the same characteristics at all as the elements that make them up. So you can't know anything about sodium chloride by studying sodium and then studying chlorine and saying, well, sodium chloride would be kind of like halfway in between the two. They don't have any of the same characteristics at all as the elements that make them up. Let's look at this. This is a piece of sodium metal. Sodium metal is very soft, solid. You can cut it with a knife, a butter knife for that matter. It has very closely packed atoms of sodium pushed together here. So these are all the same atoms together, making up the sodium metal. You wouldn't want to hold sodium metal. You wouldn't want to eat sodium metal. You wouldn't want to sprinkle it on your French fries. This is chlorine gas. It's a yellowish gas. It is made up of little groups of 2 chlorine atoms hooked together, and each of those are very, very far apart from each other, as gases are. We'll talk more about the gas state later. It is transparent and translucent. You can see right through it. If you were to breathe in this gas, it would destroy your lungs. It is a terrible gas to be around, but it is useful. You can bubble it through water and kill germs. So swimming pools will have chlorine used to kill the germs in the pool. If I were to take that piece of metal and dump it into this flask, we see that flash of light that happens, and then we will see the sodium chloride formed in there. Now this you can sprinkle on your French fries. It looks very, very different than the pieces that make them up. It won't hurt you I wouldn't inhale salt, but you know, to be around it. Too much isn't good, they say, but and this is what it looks like on the down on the atomic level. We have alternating sodium and chlorine atoms. So this has none of the characteristics of those 2 things that made them up. Now we use chemical formulas to represent compounds. Now chemical formulas is shows the ratio of the atoms that make up the compound. And sodium chloride is made up of a 1-to-1 ratio of sodium and chlorine. Now there's a whole bunch of sodiums and there are a whole bunch of chlorine atoms. When you're looking at just a really tiny grain of table salt, there are lots and lots of sodiums and lots of chlorines, but it is a 1-to-1 ratio. So we show that way as the formula that every 1 sodium has 1 chlorine associated with it. Now if we look at this over here, this is a molecule, what we call a molecule of ammonia, NH3. And for every nitrogen that's in blue, there are going to be 3 hydrogens that come along with it. Compounds and elements are both categories of pure substances. So we're classifying matter. We first have got a overreaching category called pure substances. Pure substances can be broken into two different categories, elements and compounds. You need to know the difference between them. And then elements can be further broken into metals, nonmetals, and metalloids. We will later talk about compounds more and see all the different ways and different kinds of compounds, why some of them are hooked together in this fashion in a three-dimensional arrangement and some are individual little groups like we see here. We're going to be studying this as we proceed further, but for now we are going to have a dead end when we're categorizing and classifying matter with our compounds.